Hello student, today we are going to discuss about piecewise interpolation. So here in a brief we are going to describe graphically what is the meaning of a piecewise interpolation and how this one is different from the general interpolation. So suppose there are n plus 1 nodal points, or there are n plus 1 nodes, and that nodes is a xi, I ranges from 0 to n, and corresponding value of a function be the fi, and I ranges from 0 to n. Means we have a n plus 1 nodal point and corresponding value of the function. So in a simplified form, we say that there are how many number of data? We have a xi, fi for, means we may define this one like for I equal 0 to n, and if we expand this means this data for I equal to 0, I equal to 1, I equal to 2, then there are n plus 1 pair of data f0, x1, f1, x2, f2, similarly xn, fn. Means we have a n plus 1 pair of data corresponding to the x0, the value of the function is f0, corresponding x1, value of a function is f1. Similarly, at xn, the value of the function is a fn. Means if we plot these pair of values here, suppose this is x0 and this is x1, x2, x3, and similarly suppose here xn minus 1 and xn, and corresponding value of a function if we plot nodal point on a x-axis and value of the function on y-axis. So corresponding value with the here f0, here f1, suppose this is f2, this is f3, and this value is a fn minus 1, and at xn the value of the function is a fn. So normally in a general interpolation, if we have a n plus 1 data, then we able to fit a n polynomial of a degree n. So if the number of our data is not too much large, then general interpolation give the accurate result. But if the data is too much large, means suppose there are 100 data, then we fit in general polynomial, in general interpolation we fit a polynomial of a degree 99 if we have 100 data. So as we know that as the degree of a polynomial increases, the accuracy in an interpolation also increases, but after a certain level the accuracy, as the degree of a polynomial increases, the accuracy decreases due to round off error. Due to this reason, there is a need for a piecewise interpolation. Once again I repeat this statement: if number of a data is too much large and after a certain level too much large, then if we fit a general polynomial of a degree, if we have a n plus 1 data, we fit a polynomial of degree n, then due to the round off error we unable to find out a accurate result if a polynomial of a degree is too much high. That is why there is a need of a piecewise interpolation. In a piecewise interpolation, as its name is a piecewise, means for a piece of a data we fit a polynomial. If we fit a linear polynomial for a piece of a data, and again for the remaining data for a piece of a data if we fit a linear polynomial, such interpolation is called piecewise linear interpolation. If we fit a quadratic polynomial for a piece of a data, means if we group the data in a first group, second group, third group and fourth group. In a first group, if we fit a quadratic polynomial, in a second group again we fit a quadratic polynomial, then this type of interpolation is known as a piecewise quadratic interpolation. So here, and also we know that to fit a polynomial of a degree 1, there is a need of at least 2 known values, 2 data. So in order to fit a polynomial of a degree 1 between f0 to f1, if we fit a polynomial of a degree 1 means a straight line between f0 to f1, then f1 to f2 again if we fit a straight line, and f2 to f3 again we fit a straight line, and similarly fn minus 1 to fn if we fit a straight line, means a piece of a data, means for this we fit a polynomial of a degree 1, and if we denote this one is a p11x. p11x means a polynomial of a degree 1, first polynomial of a degree 1. There are 2 means indices p11. This indices shows that the degree of a polynomial, and this indices shows the sequence of a polynomial, So if we write p11, the degree of a means we are going to fit a polynomial of a degree 1, and 1 means this one is a first polynomial that fit for the first 2 data x0 to x1. So here, and if we write a p12, meaning of this one is a degree of a polynomial is a 1, and we fit a polynomial of a degree 1 between x1 to x2. So here we write a what? Here we write a p12, here we write a p13, and here we write a p1n. So if we fit a polynomial of a degree 1 means a linear function between f0 to f1, then interpolating polynomial is known as a piecewise linear interpolation. And if we fit a quadratic polynomial, so if we write here like this one, means a px is a polynomial which satisfy for the whole data, p11 x for x ranges from x0 to x1. Similarly, p12 x ranges from x0 to x2. Similarly, we write a p1n x lies between xn minus 1 to xn. So p11x is a polynomial of a degree 1 between x0 to x1. But if we try to fit a quadratic polynomial, then what will happen? There is a need of how many known values? There is a need of 3 known values to fit a quadratic polynomial. So rather than to fit a polynomial of a degree 1 between f0 to f1, we fit a polynomial of a degree 2 between f0, f1 and f2, means we fit like this one. If we differentiate with this one by different color, then suppose here this one is a what? This one is a suppose this one is a what? This one is a first polynomial, and we denote this polynomial by what? This polynomial degree of a polynomial is a 2 and sequence of a polynomial is a first polynomial of a degree 2, that we fit between f0, f1 and f2 from x0 to x2. Means if we take three data, three nodal points, we fit a quadratic polynomial among three nodal points x0, x1, x2, then x2, x3, x4, and here xn minus 2, xn minus 2, xn minus 1 and xn. Then this one is nothing else polynomial of a degree 2 or also known as a piecewise quadratic polynomial, means a piece of a data we fit a quadratic polynomial. For next piece of a three data we fit a quadratic polynomial. Again for the next three data we fit a quadratic polynomial, and last three data we fit a quadratic polynomial. So similarly, if we fit a cubic polynomial for first 4 data and next 4 data and sequence of a 4 data, then we say that this one is a piecewise cubic polynomial. So here if we try to write here mathematically, so here this one is a piecewise linear interpolation. Here we write a piecewise linear interpolation. This one is a piecewise linear interpolation. Piecewise linear interpolation. Linear interpolation. Interpolating polynomial. Interpolating polynomial. So P11x, P12x, P1nx can be found with the help of a forward, backward, central, Lagrange or Newton divided difference interpolating formulae. If for equal, if the data is a given at equal class interval, then we use the interpolating formula for equal class interval. If the data is given for unequal class interval, then we use the interpolating formula for the unequal class interval. Similarly, as earlier we defined, we may write this one is a what? This one is a second degree polynomial P2x. You may also write this one P1x. So P2x is a what? P2x is a this P21x, x lie between, there is a need of a three data. First is a x0, second one is x1 and third one is a x2. Among x0 between x0 to x2 we fit a polynomial of a degree 2, and similarly P22x, x lie between x2 to what? x2 to x4. x2 to x4 similarly between x to xn minus 2 to what? xn. Here we fit a P2 second degree polynomial. How many number of polynomials? 2, 1, 2, 2. So there is a n minus 2 x. So this one is a polynomial of a degree 2. Similarly, if we fit a polynomial between x0 to x3, then we denote this one by the P31x, means a polynomial of a degree 3 for the 4 known values. Then again for next 4 known values we fit a next polynomial of a degree 3. So this one is a what? This one is a graphical and means a theoretical a brief concept of a piecewise interpolation. So